So today we are going to discuss about the different addressing modes and the instruction execution, which is your unit 3 in your syllabus. So first we will discuss about the different addressing modes. Then we will discuss about the instruction cycle, which will comprise of instruction cycle, fetch cycle, machine cycle, T states, and then we will see the different types of instructions in the instruction set of 8086. So now first of all we'll see what is addressing modes. Now by this time you know what is a microprocessor and what is its job. A microprocessor is something which has to be given some instructions and it executes it. So when you have to give an instruction to a microprocessor, it has a particular format. It has two parts. One is the opcode and the other is the operand. Opcode means operation code and the other part is the operand. Now there are different ways how you can define this operand. So the different ways of defining the operand is termed as the different addressing modes. Now you can see in the slide, I'm just reading the slide to you, I've already explained. The job of a microprocessor is to execute a set of instructions stored in the memory to perform a specific task. So operations require the following: the operator or opcode, which determines what will be done, and the operand, which defines the data to be used in the operation. So now every microprocessor, the machine needs to be told how to get the operands. That means the effective address is to be determined, and the different ways of determining is termed as the addressing modes. I think now we are ready to go for the next slide. So we will see now what are the different addressing modes. There are 8 different types of addressing modes. The first we discussed, that is the immediate addressing mode. What happens in this mode? In this mode, the operand is implicitly given in the instruction itself. So there are examples given here. So the operand, when the operand is given in the instruction itself, it is known as the immediate addressing mode. In this case, you must know what is the operand which you want to shift or move. If you know that, then you can use this immediate addressing mode. The next one is the register addressing mode. So what happens in this register addressing mode is that your operand or the data of the data is kept in one of the registers. You can see here, move BAS, CX, AX. You already know by this time AX is the accumulator, and every instruction or every operation results are stored in the accumulator. So these are the 2 examples given here for register addressing. That means the operand is kept in any one of the general purpose registers or any other register. Next we have the direct addressing mode. What happens here? In case of immediate addressing, the operand was explicitly in the instruction, but here the location of the instruction is given. In direct addressing mode, the location is given. So 1592 refers to the location where the data is present. So that is the difference between immediate and direct. And register indirect addressing mode. In the direct addressing mode, the address is given directly. But in case of register indirect addressing mode, the address is given in the register. You can see here BX is the register given. So suppose we can keep the address of the operand in the register. So that is why it is termed as the indirect addressing mode. You have already studied about the different registers of the general purpose and special purpose registers of 8086. So base register, base pointer, these registers are used in this based addressing mode. Here the offset address of the operand is given by the contents of the BX and or BP and the displacement of 8-bit or 16-bit. That means you can specify the address of the operand by using the BX or BP register plus an 8-bit or a 16-bit displacement. Next is the indexed addressing mode. Here the operand's offset address is given by using the SI or the source index or destination index registers and then 8-bit and 16-bit displacements. You see the differences over these things are the use of the different registers. In the based one, you can use BX and BP. In the index register, you can use SI or DI. Next, we have the based indexed addressing mode. In this case, you can use the BX BP register or SI DI register. So it is BX plus SI or BX plus DI. So BX or BP register or SI or DI register you can add. So in the based indexed with displacement mode, here you can use the base registers BX or BP, or you can use SI or DI, plus you can use an 8-bit or a 16-bit displacement. So these are the different addressing modes. Addressing modes means specifying the operand of the instruction using different methods. These are the 8 addressing modes. Now let us go to the next topic, which is the instruction cycle. Here we will talk about what is an instruction cycle, what is a machine cycle, and what is a T-state, and what is the relationship between an instruction cycle, machine cycle, and the T-states. So every instruction performs a cycle. First, you got to fetch the instruction. Next, you got to decode the instruction. You got to read the address from the memory and then execute the instruction. So you can simply write instruction cycle is equal to fetch cycle plus execution cycle. But in the fetch cycle, you got to decode, you got to read the address, and then you got to execute. So the whole 4 step, all these steps together is termed as the instruction cycle. So fetch instruction from memory, decode the instruction, read the effective address from memory, and execute the instruction. So just go to the slide, everything is explained over here. So now we can go to the next slide, which says what is a machine cycle and what is a T-state. A machine cycle consists of the steps that a computer's processor executes whenever it receives a machine language instruction. It is somewhat same as the instruction cycle, but an instruction cycle consists of more than one machine cycle. It is the most basic CPU operation, and modern CPUs are able to perform millions of machine cycles per second. So the standard step, as we already said, fetch, decode, and execute. Fetch, decode, and execute. This is the part of the machine cycle. So every instruction cycle consists of one or more machine cycles. What is a T-state? T-state consists of the unit of an operation or process within a microprocessor environment. Fetching data, decoding of codes, execution of instruction, they are individually known as a particular state. So that is termed as a T-state. So let us go to the next slide to see the relationship between these 3 terms: instruction cycle, machine cycle, and T-state. You can see an instruction cycle consists of more than one machine cycle. And one machine cycle consists of more than one t-states. I have already discussed in and have given you the slides related to timing diagrams. There you can see the t-states have been mentioned over there. Machine cycle is also mentioned there. So you can look up into those slides also. So next we can move on to the instruction set of 8086. Now, when we were talking about the addressing modes, we talked about the operand part. Now we are going to talk about the instruction part, that is the operation. When we talk about operation, we are supposed to provide some instructions. So there are 6 instruction groups in the instruction set of 8086. That means similar type of instructions which are performing similar type of functions are grouped into one set. Data transfer instructions, arithmetic instructions, logical, string manipulation, control transfer, and process control instructions. So let us see them one by one. Data transfer instructions refers to those instructions which transfers data from one location to another, like from memory to register, register to memory. So these type of instructions are termed as data transfer instructions. So the source and the destination both has to be mentioned in the instruction when we are going to use these type of instructions. The source will hold either the data, register, or memory location, and the destination will hold the address of any memory location or the register. So this is how data transfer instructions, some examples are already mentioned, you can see. Arithmetic instructions are those which will help you to perform some arithmetic operations like addition, division, increment, decrement, division, multiplication. So here in case of add, subtract, ADC means additional carry. These instructions add, sub, they need 2 operands to add. But in case of multiply or divide, there is only one only one parameter which you have to use in those instructions, because the one of the operand is in the accumulator already in case of those instructions. Please go through the instructions and you see that some of the instructions has 2 operands and some of them they have only 1 operand. So next we go for logical instructions. You will already know about the operations like AND, OR, complement, shift, rotate. So these operations are termed as logical operations, and there are the logical operations results are represented in the status flag. You already know what is a flag register and what are the different status flags we have already discussed earlier. So this is AND, OR, XOR. These are some examples of logical instructions. String manipulation instructions are instructions which helps you to manipulate the strings. They contain the instruction for movement or comparing strings or scanning, loading, or storing the strings. These are some examples. So CMPS is an example to compare the string bytes or words, LODS, loading strings. So these are some string manipulation instructions. There are more to these set of instructions. I have mentioned only a few. The remaining is your job to see the different other instructions in these groups. The control transfer instruction. These are instructions which lets you shift the control of operation. Normally, operations are done sequentially, but when sometimes we need the control of our operations to be shifted or moved to some other instruction, these control transfer instructions are used, like call, jump, loop. These are some interrupt instructions. They control the operation of the processor. There are some processor control instructions. They are used for setting or clearing the flags inside the processor. So these are some CLC for clearing the carry flag. So this way there are other instructions which are used to clear or set the different flags inside the flag register or processor. So this is all about the different instructions and instruction cycle and addressing modes of these. Go through the slides and also the different examples of the different types of instructions. This is all for today. Thank you.